All right, next problem. Here we are in the land of 9-6. First problem on the back. This shape, in spite of my massively good drawing, is virtually the same shape as the one I did as an example just a moment ago. So hopefully this was easier to do or easier to start thinking about than previously. So, same idea. If I look at this thing, it's going up. If I imagine myself walking through the slices, my slices are rectangles in the front. My front of my shapes I'm walking through, if I walk from here to here, the shapes that I'm walking through are all going to be rectangles. So because of that, I can find the area of my shape is going to be equal to the rectangle, which is going to be the base, which I look over here happens to be 5, times the height, which in fact is a value of y. Now, since I'm walking this way, since I made the height y, right, then this direction must be, oh yeah, it's our old friend x. And so I know I'm eventually going to want to write a dx on the end of this, right? And I know since this is 10 in length, and I better just make it 10 in length, this is from 0 to 10, so the only thing I have left to worry about is, how do I write this area equation in terms of x? And so I casually gave you the equation of a parabola. And so you would quickly go, aha, well, y can be written in terms of x as long as I steal that equation and make it 5 negative 2/5 x squared plus 4x. A little bit more area time, and I get negative 2x squared plus 20x. And so that being the area, I now have an area formula that I can now integrate as I walk from x equals 0 to x equals 10. And I got negative 2x squared plus 20x. And so I'm going to raise the power by 1, divide by the power I get. Raise the power by 1, divide by the power I get from 0 to 10. Plug in 10, I get 2,000 over 3 plus 2,000 over 2 minus 0 plus 0. And so I end up with negative 4,000 plus 6,000 over 6, or 2006, or I guess I can do this. 3, 3, 3, and a third. Cubic didn't give you any units, so we're just going to leave it like that. Okay? So, again, approach, find an area formula that works for you. You picture what you're walking through, figure out which way you're walking, make sure your area equation has the same variables, and then integrate as you walk from one side to the other side, walking through whatever shape you happen to be talking about. The next shape that we're going to have, is would be architecturally ugly, so therefore this would never happen in the real world, but it happens in calculus land all the time. And that is, I have a semicircular roof, okay? Whereas I'm walking from the front of the hall to the back of the hall, it gets taller. So if I were to slice it open, this is what the roof would look like. The topmost part of the roof would look like this as the sides come down. If you want to, you could picture it. You know what a megaphone is? A megaphone is one of these things where, you know, they used to use in cheerleaders, used to use these all the time, like this. If you slice this in half, so only the top part was the hall, that would be what we're talking about. All right? And so take a stab at this. Try this out. Pause the video, and I will in a moment be doing all the problems, but go ahead and pause it so you're ready to go. All right. So hopefully what you realize is if I'm walking through this, each of these slices are going to be semicircles, agreed? And the semicircles have a significant problem. And the significant problem is they're actually equal to the width. So unfortunately, unlike previous problems where I can say, well, width is this, and I just differ what the height is, the height and the width depend on each other. In fact, the area of a semicircle, well, first of all, the area of a circle, you know, is going to be area of a circle is equal to pi r squared. AP Central expects you to know that, so if you don't, you need to get on that at some point. The area of a semicircle, therefore, would be 1/2 pi r squared. That makes some sort of sense. But unfortunately, r is not what we're going to walk. I'm going to set this to be 0, 0. If I set that equal to 0, 0, then I'm walking in this direction. Okay, this is going to be called the dx direction, which means my height or my radius is actually y. And so I could rewrite this area of a semicircular equation, if I really wanted to, as 1/2 pi y squared. Unfortunately, that doesn't really help me, right? Because the height is equal to the radius, that's nice, but still doesn't actually do the problem because I know I'm going to be doing a dx equation in just a second. So then I look at the top of this megaphone, and I know the answer is written to the left, but I'm going to go ahead, we're going to work this out because at some point we're going to expect you to work this out. That's a nice line, isn't it? And so I can write y equals slope mx plus b, right? Y therefore equals, what is m? Slope is I have a rise of 4 and a run of 8, going from 6 to 2, right? So I'm going to go up 4 for every 8 I go over. So there's my slope, plus my y-intercept's at 2. I'm going to clean this up to make my life a smidge better, and I get that. Okay, so that's my y value. So now how do I find the volume of the thing? Well, I find the area formula first by saying the area of this shape is going to be each shape that I'm walking through. If I stop somewhere in this hallway, as I'm walking through the hallway, and I go, what's the area of the slice I'm currently in? The area of the slice I'm currently in would be 1/2 pi, parentheses, 1/2 x plus 2, how far I walked in the x direction, plus 2 would be my radius at that moment, because that would be my height, and my height is equal to my radius, squared. All right, so because I'm going to do some calculus on this, I might as well make my life a smidge better by getting rid of all of this fun little foiling I got to do here. So if I foil this together, I'm going to get 1/4 x to the 4th plus 2x plus 4. And I'm going to distribute my 1/2 pi through. And I'm going to get 1/8 pi x to the 4th. Why x to the 4th? That should be x to the 2nd. I don't know what I did there. Okay, x to the 2nd. Plus pi x plus 2 pi. Okay? All right, so now I find the area of this. So I'm going to now integrate from my starting point, which I set to be 0, 0. My ending point's 8, so I'm going from 0 to 8. Okay? 1/8 pi x squared plus pi x plus 2 pi dx. All right, raise this power by 1, divide by the power I get. I'm going to get x to the 3rd plus pi over 2, x to the 2nd plus 2 pi x from 0 to 8. Plug it in 8. Whew. 8 times 8 is 64. So I get 64 thirds pi plus 32 pi plus 16 pi. And that's a mess. But this is 21 1/3. So 53 1/3. Probably should add these two up first. 48 pi. 48 pi, and this is technically 21 1/3 pi. So this whole thing would end up being 59 1/3 pi units. No units, but it would be whatever it would be cubed. And so that would be my area, my volume of this hall if I wanted to fill it with balloons or some sort of nonsense, which makes no sense at all. All right, so taking a look at it, that's how we do the problems. All right, let's take a look at the next problem. On the next problem, the volume of the shape is a circle Okay, so this is a circle at the bottom. So if I look from up above, it would look like a big old circle. Okay, but the height is a square, which means this thing has got a height, so it's a circular base. So if I looked from outer space, well, I'd be better if I drew a bigger circle, but I didn't draw a bigger circle. But from the side view, what's going to happen here is the two ends of the circle have 0 base. So there's 0 base, they have 0 height. The middle, as they start to get higher, right about here, the base is this width here, which means it would be a higher building in the middle. At the very middle, it would be the highest part of the building, and then it would start shrinking again. So this building would have kind of a strange shape, like say an opera house. Okay? And so if you are looking from the edge, it also comes this way out of the board, right? It comes right at you, right? So the volume of this thing, so each slice is going to be a square as drawn on this thing up here. But the base is a circle, so it'll be really hard to do this any other way but with calculus. Okay, so I'm going to give you a moment. Think about what you're walking through. Think about how to write the area in terms of the variable you're walking, in the direction you're walking in. Oh, you could walk in the, no, you can't. So you should come up with the direction you're going to walk in. You need to write area in terms of the direction you're walking in, and then we will together walk through this problem, then integrate it and figure this out. By the way, just to save some time for those of you who can't remember things like this, the circle x squared plus y squared equals 9, which is the bottom of this circle, just for the record means it has a center at 0, 0. So this point here would be 0, 0 in the middle. And it has a radius of 3, so the endpoints, all these endpoints would be 3. Agreed? So that should help you out with sorting out how to do some of the math if you forgot how a circle works. Alrighty then, so I will catch you on the next video. Do this problem.